This is Pre-Calc Lesson 83. This is our little mini lecture. So in Lesson 83 you're learning simple probability, independent events, and replacement. So if you can remember, I'm sure you do, that probability is favorable. I always say it's favorable over total. That's how I define probability. Favorable over total. And so that's kind of what it all says on this. Oh, there's some vocabulary on this page. You probably want to know what an experiment could be, like drawing marbles or flipping a coin or something. Those are called experiments. And then the results that happen, like if you get a heads or a tails or you draw a red marble or something, those are called outcomes. And then if you list out every outcome of the experiment, that's called the sample space. And then designated subsets of the sample space are events. So, like I could say, rolling a 6 could be an event if I'm rolling dice or something. And then, so we already said favorable over total is probability. You've maybe seen one of these before. This is, a lot of times you'll see problems where they ask you something about the sum, the sum of the number cubes or whatever. You roll 2 dice, and what's the probability that the sum adds up to 8, or the sum of the 2 dice is a certain thing. So you can create one of these little tables yourself if you want, or you can just this table's on page 500 of your book, so you can just come to it if they ask you about any dice rolling problems. Basically on the inside is that like this would say I rolled a 4 and I rolled a 3, so that would add up to 7. These are all the different ways you could get sevens. 7's the most likely sum that you could get, right? Because the only way you can get a 12 is if you rolled a 6 and a 6. So this little table, you can use this sometimes to answer the questions in the book. Hopefully you know that this thing is a tree diagram. So tree diagrams are good for finding out, well, I mean, you can use these, or you can use the area model to find some probabilities. So this one's showing heads, like tossing some coins. You're tossing coins 3 times. So this kind of says when you toss the coin the first time, if you get a heads on the first toss, then you'll either get a heads or tails on the second toss. And you can follow the diagram out, and like if you want to know what's the probability that I get a heads on the first toss and a tails on the second toss and a heads on the third, well, I mean, you could follow it out and you go, oh, heads first, tails second, heads third. So it's heads, tails, heads. So, and you can follow out, and these are the outcomes right here. That's called a tree. It just models things like coin tossing, or sometimes you'll see a tree diagram with different kinds of sandwiches you can make. I see that one all the time, where it'll say, oh, we can have wheat bread or white bread, and we can have ham or turkey, and then we have, like, I don't know, mayonnaise and Miracle Whip or something, and you could make a tree diagram for that. Replacement is like, if you've ever heard of those problems where they say, oh, we have a lot of marbles in like this one, we have some marbles in an urn, and if you pull out a marble and you don't put it back, that's called without replacement. But if you pull a marble out and you put it back, it's still kind of, they're independent events. the marble pulling, but if you don't replace the marble, then that kind of changes the way you do your probability. So we'll talk about that in a second. But it definitely matters whether you replace, like if you're drawing cards and you keep it in your pocket, that's going to change the next outcome. So those are dependent events if you don't replace the marble or whatever it is that your situation calls for. So I'm going to just do a problem to kind of illustrate the replacement and not replacement and some of the other things that I just talked about. So I think one of the problems that you're supposed to do is number 6. So in number 6 it says, well, in problem 5, so in number 6 we have to look at problem 5. So this is 83, number 6. Problem 5 says there's 5 red marbles. I'll show this where you can see it once I write it down. There's 5 red marbles and there's 12 white marbles, and that's all there is. So if there's 5 red marbles and there's 12 white marbles, then I always write it like this, and then that would be 17 total marbles. Okay, and then it also says, now that was I just got that information from number 5 because it's referring to number 5. We're doing problem number 6 though. What's the probability that the first marble will be red and the second will be white if the first one is not replaced? Okay, so the probability of first one is red and the second one's white. I'm pretty sure you guys have done stuff like this before. When I pull the red one out, I'm not going to put it back in before I draw for the white. So the probability of red, we said it was favorable over total, so there's 5 reds and there's 17 total. And then now though, I took that red away, so it's gone. There's not that many reds in there, and there's actually, so that changes, now there's 1 less marble, so now there's 16. So then I can, when I draw from my white, that red one's not in there anymore, but there's still 12 whites, so I'd go 12 out of 16, and that's all. That's how you do it without replacement. Well, I mean, that's not all. You have to do your little fraction math here. So I would probably reduce this thing. Half of 12 is 6, and half of 16, oh, I could have done it by 4s. Half of 6 is 3, and half of 8. So, and then, well, 5 times 3 is 15. I don't know what 17 times 4 is off the top of my head. Let's see, 17 times 4, that's 68. And so that's what I got. And that is actually correct. So that's how you do that problem. Okay, so we're running late on the video, so I think that's all I'm going to say about that.